We present a method to approximate mesh deformations of feature film quality character rigs in real time. Here we show our algorithm approximating the mesh deformations of Po from Kung Fu Panda 3 on an iPad. The user can interactively move the hands, feet, and torso of the character. Our method then approximates the mesh deformation based on the user's specified pose. Our implementation on the iPad uses only the CPU to compute the deformation, and the approximation runs near 130 frames per second. For comparison, evaluating the deformation system on the original character rig runs at only 35 frames per second using a high-end desktop computer. In this example, we explain how our method can approximate the mesh deformations of this arm. We first use the underlying bones and joints to approximate the deformation using linear blend skinning, with each vertex assigned to a single bone. The remaining deformation shown here is approximated using deep learning methods. To train the approximator, we generate a large set of example poses covering the full range of motion of the character. The input to the algorithm is the transformations of each bone in the underlying skeleton of the character rig, and the output is the difference between the original deformation and the linear blend skinning approximation. The final deformation is approximated by adding the linear blend skinning deformation together with the output of our function approximator. In the following examples, we demonstrate how accurately our method approximates the mesh deformations. Here we show a walk cycle animation of Astrid. These meshes are deformed using the original character rig. Here we show our approximated deformations with a heat map indicating per vertex approximation errors. Finally, we show the output of our method with the texture on the left and provide a side-by-side comparison with the original animation on the right. Next, we show a similar comparison with the character Po. This character is 1.9 meters tall, and the average vertex error of our approximation is 0.16 millimeters in this animation. The deformation runs at 35 frames per second, and our approximation runs at 450 frames per second. Here we show a comparison with a walk cycle of Shifu. This character is 0.9 meters tall, and the average vertex error of our approximation is 1.4 millimeters in this animation. The deformation runs at 115 frames per second, and our approximation runs at 665 frames per second. Finally, we show a comparison with a walk cycle for Tigress. And this character is 1.8 meters tall, and the average vertex error of our approximation is 0.87 millimeters in this animation. The deformation runs at 45 frames per second, and our approximation runs at 370 frames per second. To show how well our algorithm approximates more dynamic poses, we show a comparison on Kung Fu animation performed by Shifu. The error relative to the scale of the characters remains small throughout the sequence. The largest error occurs in the legs during kicking motions, but even these errors do not have a significant visual impact on the character's appearance. We show one more Kung Fu sequence performed by Tigress. The largest error occurs in the leg when she is performing a high kick while spinning in the air. The average approximation error across the entire animation is 2 millimeters, and the largest error is 190 millimeters. Despite these errors, our approximated deformations still closely resemble the original animation. Finally, we conclude with another video of our interactive iPad application. Here the user is posing Astrid. Her mesh contains nearly 170,000 vertices compared with only 14,000 on Po's mesh. Outputting a larger number of vertices does slow down our algorithm, but it is still capable of running in real time to approximate Astrid's rig. In this example, our method is able to approximate the deformations at a rate of 35 frames per second using only the CPU on the iPad. For comparison, the original deformation system of the rig can be evaluated at a rate of only 30 frames per second on a high-end desktop.